This is what our drone looks like when it's all put together. It is designed specifically for aerial mapping. It's not for recreational use or anything. It's a single purpose. And you'll notice from the picture here up top, this is for the radio link. This is actually a parachute recovery. Okay, this is the GPS and compass, and you can see the antenna for the radio sticking up here. And these are the two servos that activate the elevons. So it's a very simple drone. It doesn't have a whole lot of servos. It has three, one on each wing and one for the parachute. That's it. Okay, and there's some reasons why we chose this particular model. I'm not a salesman for Tuffwing or anything, but we looked at a lot of them, and this was the one that kind of met most of our requirements. It is designed specifically for aerial mapping. In Canada, we have an under 2 kilogram requirement. There are stricter rules for drones over 2 kilograms. It supports many different cameras. It supports infrared, multispectral, a bunch of Sony and Canon and a whole whack of cameras. Almost any camera can be adapted to this particular system. Readily available parts and software. We can almost get parts almost overnight if we had to.
Overnight, you mean?
Yeah, if we needed parts, we could probably get them within 2 days.
Where? Not in
Out of Texas. You could get them here in Mongolia with DHL, but no, I'm not sure how long that would take, but it would be quick. Okay, it can support PPK and RTK and also long-range radios. Now, I'm sure some of you are familiar with PPK and RTK, but they are post-processed kinematic, and this is real-time kinematic. And that has to do with the accuracy of the geotags that get placed on your photos. If you're doing really precise mapping, you can use either of these in lieu of placing a whole bunch of targets down and serving them. But that requires some additional equipment which we don't have, and it's beyond the scope of this workshop. But both of these can be used with the hemisphere equipment that you have here. Excellent documentation and expert support. If you go on their website, there's all kinds of PDF documents that tell you to do whatever you need to do. It has a parachute recovery system which saves the drone. If anything happens in the air, it saves the drone from crashing to the ground. However, only use it if you absolutely have to, because the wind is going to blow it wherever the wind's blowing. And it is a very reasonable cost for a commercial drone. This uses all open source software, which is free to download. These are some of the components that are inside the box. This is a GPS, and it also has, this is a GPS compass. It's also a magnetometer and a bunch of stuff. This is the radio receiver that receives signals from your controller. This is the actual brains of the outfit, the autopilot. These are the two servos that operate the elevons. There is also an actual airspeed sensor. Most drones just use the GPS. This one actually uses a proper airspeed sensor. The advantage is you get consistent speeds and consistent spacing on your photos. There are a couple of other things. Obviously, there's a battery. and radio that aren't shown here to link back to the controller. This is a very important slide. There are some do's and don'ts that you have to do, and these probably are applied to any drone, any fixed wing drone. In other words, read the user manual before you do anything. And as Gus stated earlier, comply with all local and country laws regarding UAVs. Your UAV has almost a 1 horsepower, a 650 watt motor. So it is a meat slicer, and it will cut your fingers off. So be very careful. Okay, always turn your radio controller on before you arm your drone, and I would almost say before you even connect the battery. And make sure that your throttle is set to off or idle.
Throttle means?
Throttle power. The power is all the way back. The reason for that, if there is anything wrong, like a wire disconnected or whatever, the drone will do what it calls a fail-safe, and it will try to come back to its launch position and hover at 100 meters. But it's on the ground and in your hands. So you don't want it to start up full throttle. There is a light on the top of the autopilot that gives you all of these indications here. It's important that you memorize those and know what they mean. Okay, if any of these top 4 are indicated, don't arm the drone. Only arm the drone when you get a steady green light. It basically says that everything is in order and you're safe to fly. When you are getting ready to fly, your drone is disarmed. In other words, the propeller won't go. So you don't want, and when you push the button to arm it.
Arm means launch.
Yeah, arm means to tell it to start the motor, to activate everything. So it's normal to leave the propellers off until almost the very last minute until you're ready to fly. Because unfortunately with a quadcopter, you can stand back 10 meters and tell it to fly. With this one, you have to physically hold it and launch it. So you don't want to be near that propeller. Now we're actually going to create a flight plan for the demonstration that we're going to do tomorrow. This circular area here gets loaded automatically with Mission Planner, and that indicates a no-fly zone where you're not supposed to be flying drones, period, I guess, or there are certain regulations, and it would be country-specific. Okay, we'll go to the flight plan menu, and Gus gave me a couple of polygon files. So I will go down here, and under Draw Polygon, it allows me to load a polygon file. That is the very first polygon. Now, I already have a home position created. I can leave that home position anywhere I want. It doesn't really matter. It's just a temporary starting point. And it gets me to the right place when I hit the mission map. It launches from the point where you arm it. You put it on the ground, and you start it. That's where it launches from, that's where it lands. We will right-click, and we'll go down to Auto Waypoint. It creates a starting flight plan for you, based on whatever parameters you had in there on the last one. So now I need to know what direction we expect the wind to be tomorrow. So the wind is going to be from this corner down this way. So we want to take off in this direction. We can change this angle to whatever we want. We could fly it that way. You can see here that we're set at the bottom right for a starting point. Typically, we would launch from somewhere in the middle. The first one is there. Taking off into the wind this direction. I probably want to start from the top left. Okay? So if I change this, my point number 1 is going to be up here. So I'll be able to launch from somewhere here into the wind, and it will go directly up here to point number 1. So I can change like these overshoots and undershoots. I like to use at least 70 meters. That means it's going to fly 70 meters past the edge of the polygon before it turns. This just ensures that I get overlap coverage all the way to the edge of the polygon. Okay, and we've got overlap here. And if you look down here on this bottom area, all of the parameters will change. Right now I'm showing 159 photos. My turn diameter is going to be 42 meters. It's going to take a photo every 2.63 seconds. Okay, I have 11 flight lines. I'm covering 26 hectares. My ground resolution is 4.38 centimeters. So if I say use key to this mission, the drone will adjust its power based on whether it's going against the wind or with the to maintain 16 meters per second. Okay, we have the option here to show if we want to look at where all the photos are going to be, we just have to click on internals. And these are all points where the photos will be taken. Okay, if you want to see where the actual footprints of the photo are going to be, I can turn that on. It's showing you here the extent of these photos, because they're overlapping by 75%. Altitude here, we've got this set at 120 meters. So you can see as I increase the altitude, the whole flight time changes. The number of images drops, and the interval between images increases. Now it's 2.47 seconds. Okay, the minute I hit accept, that will be the last time we see the screen. You can see here our home position is here, somewhere close to the road. So we'll be taking off in this direction into the wind, hopefully, if we get the wind direction right. But we're going to make a very sharp turn here. So we need to put a waypoint in here somewhere. When we're done, this thing is going to land here. When it's done this last point, we'll go over here and we'll drop down in altitude here. We'll drop down some more and then we'll come in here and up. Up in this corner, you can see that I had added a waypoint in here, which allows me to turn here and then a more gentle turn here. When we're done here, we can go save waypoint file. So now, if the drone was powered up and the radio connected, all I do there is go write the waypoints. So basically it writes all of these waypoints to the drone and it overwrites any previous missions that were in there. So the drone can only have one mission at a time. Now what you can do, which is probably a very good practice, is once you've written these waypoints to the drone, there's another option here, read waypoints. So what you can do here is you can go in here and you can go clear the mission, which takes everything away. And then you go in here and you can go read the waypoints back from the drone. But in our case, we didn't have them, so we'll just have to load them back in. So what that does is you write them to the drone to make sure that there were no issues. You read them back in just to make sure that everything in the drone is correct. So when you go to the site, you set up somewhere here where you pick a decent landing spot and place the drone on the ground, because that becomes level 0. Okay, that becomes its the reference altitude. It doesn't come back to the home point, it comes back to the point you launched it. So all you have to do now is go to the site, put the drone together, collect all the electronics, make sure everything is working correctly, and when you get green lights and your GPS has got a decent position, you're ready to fly. Someone holds it here and the other person switches this to auto. The minute he does, it'll go to full power. You just release it, and you start always in FTW, which is fly-by-wire manual. So if all goes well, you don't do anything until the thing comes back and lands in the grass. If things go haywire, you can switch to manual, fly it yourself, not recommended unless you know what you're doing, or the parachute button is back here. There is a radio in here. This just connects to the computer, and so you can monitor the progress of the drone as it flies on the computer. So you know exactly where it is at all times. So right now I'll repeat a couple of things that Gus has gone over, but then we'll leave that behind and get on to the fun stuff. The two common types of UAVs used for mapping are quadcopters and fixed-wing aircraft. Each have their advantages and disadvantages. Quadcopters are easier to operate but limited to the area they can cover due to endurance. Fixed wings are a little more complex but fly faster and can cover much larger areas. We will be using Mission Planner software to conduct mapping missions with the Tuffwing UAV mapper. A little later on, we're going to unpack it out of the box and put it together so you can see how quick it is to put together. We'll do that a little later, but we'll run through this Mission Planner thing first. Mission Planner is open source software and free to download. Mission Planner software is used to not only plan your missions, but also to control all aspects of your UAV. If Mission Planner can get complicated, there are over 500 settings that you can change to control everything about your UAV. Mission Planner is the most widely used flight planning software because it was the first one. Mission Planner is the critical part of any mapping mission. If you make a mistake with Mission Planner, chances are you're going to have a crashed or lost drone on camera. So it's very important to understand, get to know Mission Planner. I've kind of broken it down into about 7 steps here. We'll go through each one individually after I read the list here. The first thing you do is start Mission Planner and zoom to your area of interest. You can right-click in your area of interest and set a home location. Then you right-click again and select Draw a Polygon and define the polygon around your area that you want to map. And then we right-click once again and we select Auto Waypoints Survey Grid. When we do that, Mission Planner will create a survey grid within the polygon that we created. Okay, we then adjust a bunch of camera settings and mapping parameters, and Mission Planner will adjust our flight plan based on our requirements. And the very last thing that we have to do is set takeoff and landing points based on wind direction and speed. You'll see a little later in the when we go through these step by step. You then take once you've set your takeoff and landing points, you transfer your flight plan to your drone and go fly. It is normally done with a radio connection because the cables are too awkward. Okay, now we will go through each of those 7 steps and we'll show you what the screens look like and what you'll actually be setting. So we'll go through each of these kind of in order again. This is the very first screen you'll see when you open Mission Planner. By default, Mission Planner will open up a Google Earth image of the world. If you notice on here, there's some little purple circles. Those are supposedly no-fly zones. Okay, this is the screen that you'll see when the drone is flying, and it will have things like altitude and ground speed and waypoints. All the flight information will be here, and up here you'll see the orientation of your drone. This is called a HUD or heads-up display. Yeah, if you're a pilot, you'll be familiar with those screens. Okay, that's the very opening screen. We will select flight plan from here to take us to the next page, into our area of interest, whatever that happens to be. We have right-clicked and selected this point as our home point. We then right-clicked again and set the 4 corners of this polygon to be the area that we want to take pictures of. If you look on the bottom here, you'll see a bunch of information across there that tells you waypoint radius and loiter and default altitude. This information is important, but it becomes the default every time you use it. So you really only set it once. And out in this corner over here, I can set what I want to use for a background. I can select about 25 or 30 different backgrounds, like Google Earth, hybrid satellite map, Bing, ARC maps. There's a whole mess of them. There's a bunch of Chinese ones. There's a whole mess of them that you can select. So choose whichever is most suitable for what you want to do. But I selected some Chinese Google ones that appear to be out about 1 kilometer in registration, so don't use those. They're really nice images made by Google, but they don't seem to be registered properly. So now we have defined our area interest and set our home location. We'll go on to the next one. When we will right-click again in the middle of our polygon and select Auto Waypoint Survey Grid. And you can see on the graphic here that Mission Planner has created flight lines for that polygon that we've picked based on whatever parameters we have set in here. Now we'll go through those in the next slide. Any change you make here is automatically reflected over here. You can change cameras and altitudes and the angle in degrees and your flying speed, and they'll all be reflected over here. And you'll notice that we have clicked Advanced here, Advanced Options. That's what brings up the extra tabs here and gives you extra options, which we'll see in the next slide. These are the 3 menus that you'll see from the previous screen here. These 3. This is a graphic of each of them, and you can set all the camera options here. If your camera isn't on the list, you can actually just take a photo and Mission Planner will calculate all your camera parameters for you. It'll calculate focal length and pixel size and all that kind of stuff. Mm-hmm. Okay. In the second screen here, This is where we set the parameters that kind of dictate our project, and they're going to be whatever your project requires. Overshoots and undershoots, this is how far past the polygon the drone will fly in order to make sure that it has proper coverage. Right here, we can tell it what corner we want it to start from. Okay, we can tell it here how much we want the photos to overlap. This is forward overlap and this is side overlap. What you select here will have a huge bearing on how many photos you end up with. The more you overlap, the more photos you're going to get. Okay, the more your photos overlap in both forward and side, the more they overlap, it's going to take more time to process them, but the results will be better because you'll get more matching points. If you need a really good map, you could go to 80 and 80%. I wouldn't recommend going farther. Okay, in conventional photogrammetry, I wouldn't recommend that you go below 60 forward and 30 side lap. So for this one, 80 maximum and 60 minimum. And for this one, 30 minimum and maybe 70 or 75 maximum. Most of these options here, I don't know why we would use them. They may not be for, you don't need heading hold because we're doing autonomous missions. I think the only time you would use any of these is if you're actually flying it yourself, not doing it autonomously. Yeah, automatically. Okay, and this is the camera information. And like I said, if you don't know it, you can take a picture and load it from a picture. It will read it. But it does have a huge list of common cameras that are used. Now down at the bottom here, this is very important. This is how the camera is triggered. And normally we would use trigger by distance. We want the photos to be evenly spaced.
Trigger means?
How often the pictures are taken and how they're taken. Yeah, the only thing we would be interested in here is this one right here, trigger by distance. And once you do that, the rest of these don't really matter. And this, I would just leave this checked at all times, and we'll see in a subsequent slide why we do that. The reason you do that is if your flight lines are close together, it will skip over and maybe not do the next flight line. It'll skip one or two so that it can make a reasonable turn, and it will come back and pick those up after. Because a fixed wing cannot turn as sharply as a quadcopter. This just allows it to make smooth turns. When we're all done with our parameters here and we're happy with everything, we hit accept right here. Once you accept it, that screen disappears and you can't get it back. Mission Planner does not want you to go back and change things here because it could have drastic results. So they once you accept it, they go right on to the next one and you don't see that screen again. After we've accepted it, we will see this screen here, and this screen will show us our flight lines. It will show us our lead-ins. You can see in this case, this is our home position. And from our home position, this thing will go to line 1 here, and it will fly this line, and will come back, and it will fly these. Now, this is not a very good flight plan. This is just a sample that I did, because you can see these are very sharp turns, which we don't want. So we have the option to change those in the previous screen so that we can smooth out these things. This is probably not the best example I could have used here, but nonetheless. Okay, so this is our flight plan, and you can see we're going to start here, and we're going to take off and fly here and fly line 1, 2, 3, 4, all the way here, and then at the end, we end up here. We're going to come back and land here. This thing at the bottom lists all of your waypoints. This is open to editing, and this is where we will be adding takeoff and landing waypoints. Every time that aircraft has to do something, it's a waypoint. Even if it's a change altitude or change speed or something that's unrelated, it still requires a waypoint. This is another one here, and you'll see the waypoint listing after. And I've put the wind direction on here. This is the big difference between a quadcopter and a fixed wing. The wind is a critical component for fixed wings. For instance, if the wind was blowing 20 kilometers an hour and the drone is flying 20 kilometers an hour, if you were to land downwind, it would land at 40 kilometers an hour and land very hard. It would be double what the drone is flying. And the other way around, if you landed into the wind, you're going 20 and the wind is blowing 20, this thing is virtually just going to settle. So the wind is very critical, and sometimes you can't do this until you actually get to the site, so you may have to do this, you may have to finalize this when you're at the site. And you can see here, if I can do this, you can see here that we have taken off from here. We have flown out to here. And I have added a waypoint here so that it doesn't need to make a really sharp turn. Okay, this flight plan is designed so that these turns, none of them are less than 90 degrees. And remember when we checked the little box that said break up lines? That causes this to jump from line 1 over to line 3. You can see here, it goes up here and it goes across and it comes down on this line and it picks this one up later. You can see that it skips lines. That makes the turns much easier. Because if the drone has to make a very sharp turn to get started on a line, it sometimes has a hard job to get back on line, and you get kind of crooked lines. Okay, and when you're done and it's time to land, you're at 100 meters, and so you add in waypoints here to drop the drone down and get it lined up into the wind to land properly. And that's what this line does. It drops down here, and then it comes in here and lands here against the wind. And these are the waypoints, and you can see here where I have added in waypoints. There's this takeoff one. The drone will, when you launch it, hand launch it, it'll immediately try and climb up to 30 meters altitude. And then at the next waypoint, it tries to get to 100. Well, because it says, see right here, it says 30. The takeoff waypoint automatically goes to 30 meters. And that's just the default that it uses. It's always worked. There's no need to change it. So you can go through all of the waypoints and you can look at the altitude, the lat longs, the gradient, and the actual angles up or down. So you can look at every leg between waypoints, and you can tell whether the plane is flying level, going up, going down, what speed it's at, what altitude it's at. So going through these changes, like this do set.
Can you set it manually?
What's
you
that?
set it manually or
Yep.
automatically?
No, you can edit that till the cows come home. Okay, so this is your final edit, and you need to go through this with a fine-tooth comb because this is what gets loaded into the drone to do your flight. So then, this is a picture of a laptop with the little radio attached. This is what communicates with the drone, and as the mission is flown, you'll see this airplane follow the flight lines, and you'll follow its progress all the way through the mission. In this graphic here, the purple lines show what has been flown, and the ones that haven't been flown are still yellow because we're in the middle of the mission here. And you can see that this is a nice flight plan because all the turns are gentle. There's no really sharp turns. So you can see here that our photos will be on the line. You can actually see here on this corner right here, you can see where one of these lines is going to miss the intended line a little bit, which means that I probably should have put a waypoint further out to give it more time to get lined up on this particular line right here. Can you see that? Where it comes down here and it misses. So I did that just to show you why we try and make the lead-ins and the corners as smooth as possible. This is exactly the same way. I've been doing photogrammetry for longer than Deggy's been alive, and this is exactly the same procedure you do for conventional photogrammetry with a powered aircraft. And this is a plot of the actual flight. Mission Planner creates a telemetry log for every mission, and you can go back and plot your exact mission, and this is a plot of this mission as it was flown. You can see exactly what the mission covered, and you can see right here where this line is going to miss a little piece of that corner. Okay, and all the while the mission is going on, you can switch back to the flight data thing, and you can check your ground speed, and you can follow it along on there as well. Normally we don't. But my intention here is to take one of the areas that somebody had requested, and we're actually going to do a flight plan here before we go out to do that. So, and I'm going to be asking you guys what parameters I should set. I'm going to ask them how much overlaps and how much lead in and what direction I should be flying. Okay, so you can play this even as an animation and have the little airplane follow it around if you want. It doesn't do anything for me, but this is actually plotted the way it was flown. So that's all I'm really interested in. The telemetry, so the telemetry logs you can download off the drone and look at the mission after. Normally, if the mission goes well, you're probably not going to do that. But if if you end up with gaps or something, you might want to. The telemetry log not only has the flight information, it has all the information about batteries and IMUs and how many amps the battery has drawn, and you name it. It's in this telemetry log. So if something goes wrong, you'll find it in there. Battery condition, ground speed, you name it. Okay, Mission Planner also, because Mission Planner is a modular system, and the camera is not built in because you can use different cameras. The images are not automatically geotagged
For this one.
for any mission you do. So Mission Planner has a utility to allow you to add those tags. Mission Planner has a utility that allows you to put lat longs on all your photos. It does that by comparing the timestamps from the camera and the onboard GPS and corrects for the little difference, adds the time, adds the lat long. There are a bunch of YouTube videos. You can click on any one of these links and it will take you into these videos, but the translation to Mongolian is not great.